In this class, we are going to start a new topic which is called as fast Fourier transform, which will usually be abbreviated as FFT. Okay, as I told you in the introduction of this unit, fast Fourier transform is not a separate transform like your DTFT or DFT or Z transform or so. Okay, this fast Fourier transform, this is an algorithm or a technique which reduces the mathematical computations that are involved in computing DFT directly using the formula. If you can you say the formula for DFT? What is the formula for DFT for finding DFT? Yes. What is the formula for finding DFT? How it will be represented? X of k is equal to summation n is equal to 0 to n minus 1 x of n. Yes, e power minus j, you don't remember, 2 pi nk by capital N, where k is equal to 0 to n minus 1. This is the formula for DFT. And this formula of finding discrete Fourier transform, it involves many complex additions as well as complex multiplications. You know this, right? While solving problem, because of this e power minus j 2 pi term, you might have computed many complex additions as well as complex multiplications. So if I solve this DFT problem using this formula directly, the number of computations, in the sense the number of complex additions and multiplications that I have to perform for solving this will be more, and it will take more time. Okay, it also will take more time. So to speed up the process, of computation of DFT, we are going for a different algorithm, or you can say it as a technique, which is called as fast Fourier transform. That is why the name itself, they have mentioned it as fast. It's going to speed up the process of computing DFT by reducing the mathematical complexity involved in it. Okay. And if you take this, it is given here clearly. It is an algorithm. It is not a separate transform. Have it in mind. It is an algorithm to compute DFT with reduced number of computations. Okay, with less number of computations. Computations are nothing but complex additions and multiplications. And how this FFT is being done, how this algorithm is being executed is, it is done by decomposing a n-point DFT into successively smaller DFTs. As we did in sectioned convolution, here also what we are going to do is, we are not going to take the n-point input sequence as such. X of n, if it is an 8-point sequence, we will not be taking 8 points at a stretch. Instead, we will be decomposing that n-point sequence into smaller sequences and then compute DFT for those smaller sequences. Okay, that is why this particular technique or algorithm is also called as divide and conquer approach. We are going to divide this. We are going to segment the given sequence into smaller sequences, and then we are going to compute DFT for these smaller sequences. Finally, we are going to club all the outputs to get the endpoint DFT output. Okay. Now, you take down this. This will be asked in 2 marks. This will be asked in 2 marks. What is the computational complexity that is involved in performing direct computation? Direct computation of endpoint DFT takes these many complex additions and these many multiplications. Okay, for if at all I compute DFT using the formula that we write here, that we have written here directly, it requires how many additions? N into n minus 1 number of additions are needed, and likewise n square number of complex multiplications are required. Okay. For direct computation using the formula method, these many additions and multiplications are required. Have you noted this down? Likewise, if I use FFT method, FFT we have radix 2, radix 4, like this you have many radixes. Okay, and in your syllabus only radix 2 is mentioned, radix 2 FFT is mentioned. Okay, and if I perform the same n point DFT using radix 2 FFT, radix is nothing but the base, radix 2 FFT, the number of complex additions that is required to solve the problem is n log base to n. Likewise, the number of complex multiplications required to solve the problem is this, n by 2 log base to n, where n corresponds to the number of points, 8 point, 4 point. Okay, so if I use radix 2 FFT method, this is the number of complex additions and multiplications required to be computed to solve the problem and get the result. Okay, so you have to compare the mathematical complexity involved in direct computation and radix 2 computation, right? This formula will be asked in 2 marks,